3.4. Graph linear inequalities in two variables. So graphing linear inequalities in two variables. Basically, we are presenting the solutions of this inequality in graphical format. So here's a few steps that I want you to follow. First, you're going to be graphing a boundary line. And when you draw a boundary line, depending on the inequality symbol, you're going to be using either a dashed line or solid line. If it is a less than, or if it is a greater than, then we will use the boundary line to be a dashed line. Okay? And if it is a less than or equal to, or greater than or equal to, then we will be using a solid line for the boundary line. So dashed line basically means the points on that line is not part of the solution. A solid line basically indicate that the points on the line, on the boundary line, is also a part of the solution of this inequality. So after we draw a boundary line, then we're gonna test the point. Okay? When you test the point, that must be not on the boundary line. The point that you pick cannot be on the boundary line. So if it's satisfied, if the testing point satisfies the inequality, then we shade it on that side. Otherwise, we shade on the opposite side. So first example, to graph the solutions of a linear inequality, first we're going to draw the boundary line. So let's put this into slope-intercept form, right? 2x plus 3y is less than negative 15. Write it into slope-intercept form, which is adding 2x on both sides, and then divide both sides by 3. So that gives us y is less than 2 over 3x minus 5. And you want to put a note right away. The boundary lines will be dashed line. Okay? The boundary line will be a dashed line. Because it is the less than inequality. Then what we're going to do is we're going to draw the boundary line. My y-intercept is negative 5, which is way down here. And then I'm going to count the slope, which is go up 2 and then to the right 3 units. So 1, 2, 1, 2, 3 units to the right. So here's another point. So now this is the part that most of the time we do make mistakes on the test because we are rushing and then we tend to graph it very quickly. So we forgot to put a dashed line. So here's a dashed line. Okay, here's a dashed line. And you need to put. So now we need to know which side is the solution. So we have to test the point. So step 2, we're going to be testing the point. So whenever it's possible to use 0, 0, then use 0, 0. And in this problem, I can use 0, 0 as a testing point because 0, 0 is not on the boundary line that we draw. So substituting back into the original inequality, right? Original inequality. So that will be negative 2 times 0 plus 3 times 0 is less than negative 15. So 0 is less than negative 15. That is what? False. Right? 0 is less than negative 15. That is false. So that tells us this side of the line is false, meaning any point that you pick on that above the line will give you a false statement, meaning no solution. So the other side must be true. So you only have two sides, so either one side is false, then the others must be true. So we shade the side that is true, meaning it is the solutions on that side. Right? Those are the solutions on that side. Now, example 2. Graphing linear inequality. Again, first step, we're going to draw a boundary line. Right? In this case, our boundary line is solid because the inequality symbol is less than or equal to. So write it into slope-intercept form, 2x minus y less than or equal to 3, subtracting 2x on both sides. That gives us negative 2x plus 3. And finally, I have to divide both sides by negative 1. So so whenever you multiply or divide by a negative number, the inequality symbol switch it around. So you have to remember that. Greater than or equal to negative 2x plus 3. You divide by negative 1 divided by negative 1. So which gives us y is greater than or equal to 2x minus 3. So now we can use the slope and the y-intercept to graph it. So my y-intercept is negative 3, which is right here. And the slope is 2, so that means 2 over 1. So I can count the slope, go up 2 units, and to the right 1 unit, which is here's another point. And if you want more points, you can continue counting as usual, right? Otherwise, we can just draw the line. And this time the line is a solid line, so I can just draw a solid line. Now the next step will be testing the point. Okay, testing the point. So when we test it, again, 0, 0 is not on the boundary line, so I'm going to substitute 0, 0 into the original inequality, which is 2 times 0 minus 0 is less than or equal to 3. So I got 0 is less than or equal to 3. This is true. So the point that we test, it happened to be a true statement. So therefore, that side is true and the other side is false. So we shade it on the side that is true, which is the solution. And that will be the end of this section.